pop in a minute ago, but I'm not seeing him.
Can you
Oh,
repeat the
good, good.
information, please? We weren't able to hear.
Yeah, I thought I saw Rick pop in just a minute ago, but I don't see him here now.
Okay.
Is
Hey,
he back?
I'm here.
Oh, okay. I just don't see you. Okay, you'd probably rather not see me too. Oh, there
Yeah,
you are. Okay, yeah.
we can see you, Jimmy, but Rick is not on the camera for us.
Oh, well, he's on my screen.
Okay. Okay. So we can start
Okay.
when you want.
Yeah. Okay. Well, my agenda is that I have a list of questions to ask him. And did you get to see the review sheet that I sent earlier?
Yes.
Yeah, okay. You can look at it if you like. I'm not going to go over it piece by piece, but I use it for reference to get some of my questions together. If you had a short overview of your project you wanted to do, I'm okay with that. Otherwise, we can get just straight to the questions and answers.
Okay, we can go straight up to the questions.
Okay, good, good, good. Let's see what I got then. Let me turn on the light so I can read my notes. Okay, from our previous conversations, we had an issue with the steel inserts in the nose cone, but apparently you've found another solution for that.
Yeah, actually, we don't have
Do you remember
a stability problem anymore. We are using the same aluminum tip that we were using in the start of the project.
Okay,
It's a 10 inches long aluminum.
okay, good. Oh, you have to look at it? Very pretty.
Right. Rick, are you saying anything? If you, Rick, can you hear us?
Yeah, I hear you. I see
Okay.
everything.
Okay, we just heard something going on in the background and it sounded like someone trying to talk, but not coming through well.
Well, unfortunately, here in the store, they got a music and speakers going.
Okay,
Oh,
no
that.
problem.
Okay. Well, as long as they play music I like, it's all right with me. Bach. I like Bach.
I don't think Walmart does.
Okay, so no, okay. Can't even buy the records there anymore. Okay, so nose cone issue solved. Great idea.
Yes.
Another thing that I ran into in the this sheet was about I didn't think to ask about this before, is a recommendation of having something to guard against friction of your shock cords against the the rocket tube upon descent. Because when things rotate, it can wear out the shock cord somewhat. I take that more as a recommendation than a requirement. But
Okay.
I wondered if you had anything.
So actually, on the main fuselage, we don't have any system that remediates
Yeah,
that problem, that lessen the
yeah,
friction between the shock cords and the main fuselage. But the
yeah.
section from the upper connection that goes to the eye bolts to the end of the fuselage is short enough
Yes.
that we don't think we have any problems regarding the friction and the angle that
Okay.
the fuselage needs to be. Okay. Me mandou um ok.
Okay. I'm okay with that. Yeah, I'm fine with that. What I'm hoping to do is to avoid you having any uncomfortable questions when you get to the final review. So here's a suggestion on that. If your final reviewer has a problem with unprotected cables, just carry a bunch of duct tape and wrap it with duct tape at the point where it hits the rocket
Okay,
tube, and that should
then
be
it's
adequate for that purpose. It's
Much
not a,
better.
not an elegant solution, but it would be a
Yeah,
functional one, I believe, and get past
don't
safety
worry for
review.
them.
Yes, cost effective.
I don't know about elegant or not, Jimmy, but that's what I tell all my teams to do. Just duct tape it right where it meets the
Oh, okay.
airframe interface. How do you normally tell people to do it?
Eu acho que a coisa foi interessante, tipo, mandar, tipo,
Yeah. Well, that's not in my repertoire. I don't normally do that myself and don't normally recommend it. It just kind of popped in on this sheet and thought it might be a question you'll be asked at the final review.
I don't know if there might be a problem with that recommendation because our tolerances between the nose cone coupler and the main fuselage is small enough that I think a duct tape would be sufficient to not allow the connection between both parts.
Okay, so that might not easily work on your rocket.
Yeah.
Okay, well, just think of how you might address the question of is your shock cord protected against friction at that point? And if you're convinced that it will work, then just present that to the reviewer and it'll probably fly.
Okay.
Or if you can think of something like I've seen people use like Nomex sleeves that go over the shock cord. So if you had
Yes,
something of that sort, you could use easily. That's thin enough it would fit.
yeah, the
Bring it with you.
protection on the shock cord itself will be easier to implement.
Okay, excellent. Okay, I've seen pictures of your rocket, but I don't know that I've seen an open rocket or other simulation. Has that been in? I might have just missed it, but what I'm wondering is how your fin can is attached to the motor tube. Apparently, your motor tube is the aft end of your rocket, correct?
Correct.
Yeah.
We will show you how it's connected. So this is our fin
Yes.
can. It's not fully finished yet,
Very pretty.
but
Yes.
all the structure is
Well,
already ready. Just the painting is missing right now.
okay. Okay, good.
So this is our motor tube. It's not fully finished yet. We will be finishing in this
Okay.
in this week. So here we will
Okay.
have 16 bolts that connect the nozzle. Those same
Okay.
screws will be used to fixate the fin can. And one slides.
Okay.
Agora calma aí. Ajuda aí. Okay. And it stops when it hits
Okay,
the,
yeah.
the inside edge that of the bolt tail. Ah, não precisa. On the
So,
on the leading edge of the bolt tail, we will apply a silicone filler right here that serves both as a aerodynamic solution and a fixation solution.
okay. And is that the main thing that's going to hold the fin can onto the motor tube?
No, the nozzle screws will be the main thing that holds the fin
Okay.
can to the motor tube.
Good. That's what I was hoping to hear. Yes. Something very sturdy. Okay. Well, that brings up another issue, and it's a requirement that was added actually at the request of your advisor that steel nozzles could be used in sugar motors at this competition. And a
Yes.
good thing, in my opinion. But a little addendum to that is that the nozzle throat, the throat of the nozzle has to be recessed inside the motor tube. And from your drawings and pictures, it wasn't real clear to me where your nozzle throat is.
So with that question, we have a little problem in how it is described in the DTAG, where
Yes.
in our project, the nozzle throat is recessed just within the motor tube, but I don't think if it's enough for you.
Yeah.
Yeah, we'll be opening a CAD right now to show you.
Okay. Well, when I looked at the photos, it looks like you have a fairly long nozzle throat. You'll have your convergence and then a cylindrical throat and then a divergence, right?
Right.
The question would be is where exactly is the nozzle throat if it's that long?
So
To me,
for me, the nozzle throat is just the smallest section of the throat itself. So it's just a
okay,
point for me. I don't consider the nozzle
right.
throat a component that has a long diameter.
Okay. Yes. Well, you, you may have answered my question, but let me be clear on that. The section that looks cylindrical to me in the picture is not truly cylindrical. It's slightly tapered. Is that correct?
No. The outside of the graphite is fully cylindrical, but the inside has a bell curvature. We will
Okay.
show you
Well,
with more details right now.
graphite. I remember seeing what looked like a steel nozzle.
Okay, eu não estou conseguindo mostrar.
Is your nozzle now graphite?
Okay, so we have a kind of a composite nozzle where we use three materials. Where we use. I hope you can see well right now.
Oh, okay, I can.
Okay. So the pink part is made out of steel. The orange part is the graphite section, and the other two are both a phenolic composite made out of cotton fiber and phenolic resin. So,
okay, good. No, go for it.
No, that's it.
Well, that pretty much answers my question because what I was seeing was the outside and inferring that the inside paralleled it, but it does not. And your nozzle throat is about at the middle of that straight section.
The nozzle throat for me is this straight line where my mouse is on in the middle of the screen.
Good. I agree. Now, is that recessed within the motor casing?
Yes, it is. The motor casing ends right here in this line, and the throat is this
just
line.
barely then.
So it's
okay, but I think that'll pass. Yeah.
Okay.
Okay, good. I think it'll pass. Give it a check mark. Oh, another question about your motor. I'm going to jump around quite a bit if you don't mind. It's kind of what I do. Is you had the earlier motor Cato, which was spectacular, by the way. I really enjoyed that, except I knew you would not like it near as much. That's okay. I feel for you. I've done a few of those myself. And you're wondering about why. And one of your suspicions was debonding of the grain inhibitors, them coming loose, and gases leaking to the outside of the grain. Are you using anything to ensure adhesion of the propellant to the inhibitor, or using a glue or something?
No, we do the casting inside the inhibitor. We actually did a static fire yesterday. We use a different material for the inhibitor. Okay.
Oh, that's good news. I want to hear about that. But tell me more. You are using something to adhere the propellant to the inhibitor, right?
Not a component. We don't use any glue. We just cast the propellant inside the inhibitors. Como que fala que é o lixo? We send the inhibitors on the inside to make a better connection between.
Well, I suggest, I'm not supposed to give you recommendation, but here's something I do because I have had that problem, is to coat the inside of the casting tube with epoxy before you put the propellant in. That way the epoxy bonds to the propellant and it's a much stronger bond than it bonding to the paper.
Mhm. Uh,
It
that's
also
a
makes the
good.
paper a better inhibitor
Okay,
and makes
that's
it smell a lot worse.
I believe it. So we actually did a static fire yesterday, but we
Yes,
were
tell me
very
about it.
successful with it.
Yay.
We had a minor problem screwing all the necessary screws because we were
Yeah.
using a fiber a fiberglass wound aluminum tube that was very thick
Okay.
and was kind of hard to screw all the screws, but all went good. We had a we collected just the pressure data that was essential
Okay.
for us. Where we
Okay.
in the next weekend we will be using the aluminum tube that you see right here for the next static
Okay.
fire.
Yeah. Is that the one you're doing on the 17th?
Exactly. Yes.
Yes. And the one you did yesterday, was that also a full-size motor?
Yes, it was a full size motor, as you can see
Okay.
right there. We
Oh,
can get
okay. Wow. Impressive.
so
Yeah.
as you can see, it has a very thick fiberglass
Mm-hmm.
layer.
Yeah.
So this one is very recessed within the motor case, the nozzle, but the actual one will be 5 centimeters less.
Mm-hmm.
Okay. Okay. Yeah.
Well, that's very nice. Very clever. And I'm glad it worked. Well, that brings me to another question is about the paying of the late fee. And I think I heard from Andy Berger that somebody had already okayed your delay on that. Is that correct?
So a taxa de inscrição. Quem vai pagar tarde.
Okay. We just received earlier email from Andy, the executive director, and he said that he highly recommends that we pay the rocket fee on the deadline. So
Yes.
we're gonna pay it today.
Okay, well, I was hoping to offer you some relief on that, but that was kind of the word I got too. Although I've had a conversation with them on Slack and I haven't seen his latest response. Just so we're both informed, let me find Slack and see if he's responded yet.
Is that fiberglass around your motor
Okay.
case?
Yes,
How
there is.
thick is that?
It's a about 1 inch in about a 1 inch layer.
Is that like
Okay.
how much weight does that add to the motor?
No, no. So that case right there weighs about 90 pounds, I think, but it's not able to fly.
Mm,
The final version will be just a aluminum tube.
Okay,
okay.
why did you have that fiberglass on your test version?
So we had a
We
the-
conducted this test just for validate our ballistics. The previous test we have a Kato, and this test was to just verify if everything internally
Yeah.
is burning well. The last test we have all the calculations and simulations of the motor was okay. Everything is under 2.1 of safety factor, and unfortunately the test was the ballistics don't match. So this test is just to verify that. That is to prevent another explosion, and we could validate the configuration of the grains. So we have applied any modifications of the grains, the internal, the coupling, the all the integration of the grains in the liner. We are not more epoxying them. We are just
Using spacers between them.
using spacers, and these spacers is also made of the same material of the liner. So we did this test. We have conducted this test just for validate the pressure.
What pressure did you get to? What was your max pressure?
So in the first test, we collected a data that goes up to, in PSI, I think it's about 1500 PSI. In the test that we did yesterday, we collected about 400 PSI. We actually don't think that the pressure is totally correct. We have another methods to validate that pressure, but we will need to work on them for our next static fire.
Okay, 1500 PSI is way too much for a
Yes.
motor.
It went double the maximum pressure expected.
Yeah. You're going to do one more test?
Yes. Next
Is that going to
Saturday.
be without the fiberglass, or is that going to be also with the
Yes,
fiberglass?
without the fiberglass, the final version of the motor.
That
The
you're going
one
to
that-
test.
Again?
You're going to static test, right?
Yes, a static test.
Okay. All right. I just want to make sure that your flight motor configuration is going to be tested.
Yes,
Yes.
it will be.
Next week.
Good. Did you happen to measure the thrust of the motor that you just fired?
On this test, we didn't measure the thrust. On the previous one, we did. So the maximum expected thrust is about 8,000 newtons.
Okay.
But on our first static fire, we collected up to 1,300. So it was a bit above.
Yes. For a very short period, I bet.
Yes, it was. I think the duration was 600 milliseconds until it exploded. It was very fast.
Yes. The reason I say is you can get an estimate of pressure from the thrust, if you know what the thrust is.
Yes, you can.
Yeah.
You can correlate
As a double check.
almost a one-to-one.
Yes. Okay. See what else. Oh, I had a question about your igniter. It sounds like you have a very clever system of a 3D printed case that holds the powder in place. Can that be removed and replaced at the launch pad?
Yes, it can. It's just a simple cylinder. Do I need to describe the ignition system?
Not too much. Just
if you can.
If you like, that's fine. But I always love a clever new idea.
Okay.
But it will go through the nozzle throat, right?
Yeah, it goes through the nozzle throat.
Good. I had a team last year that had a very clever design, but it had to be installed when the motor was assembled, and that won't fly at IREC. So I'm glad you're not doing that.
Yes, we know.
Yeah. Okay. What else? Okay, I saw your electronics and did some testing. Oh, and by the way, whoever does your videos, my compliments. Who made all those little videos that I saw just now when I reviewed you?
Vídeos do third. Os vídeos testes do third. Ele falou que gostou.
Yeah. Anyway, that's a very good idea, and I enjoyed seeing them. And it's a lot better than reading, and then wonder what actually really happened. So thank you for doing that. But one of them I saw was in the electronics. You had an assembly of electronics you were testing, but it was mostly is on a lot of different breadboards. Has that all been assembled yet into its solid package, or is that still in the works?
I will call the electronics specialist right now that can answer better.
Oh, okay.
Yeah. So, sobre a eletrônica, toda ela foi testada tipo placas fora da montagem final.
Yeah.
Alguma já foi testada no modelo final.
Integrated?
Você consegue começar?
Okay.
Quero passar aqui no slide para aqui.
we test the electronic all in the protoboard using model of dates with our test rocket FTK and scaling it for the highest of morphos. And we have the correct ejection of the skips.
Okay. Very good. That looks very nice.
Yeah, this is
So every is
board. With we have
Okay.
two barometers. One is the PMP 390, and one is the MS 5803 with one BA. It's this tool is only for redundancy. Yes, the rocket only eject the parachute if the tool is okay.
Okay.
And we have a Mac lock using the ADXL 350 and tray with Mac velocity. And they have the maximum capacity of collected data is 200 G per G. So it's very good. More question?
I like the design.
I
might copy that one.
It's very good. And in this side, we have two COT systems. The Easy Mini and the Federate GPS.
Okay.
So inside have all batteries here.
Okay, and the batteries are secured. Looks like they're locked down pretty tight. The batteries can't move.
Yeah, it's attached for here.
Good.
And here it's top.
Good, excellent. Very nice. Thank you.
Thank you.
Now you also have a payload. Is it completely separate from the avionics bay?
Yeah, it's completely separate. But Joseph will explain to you now.
So about the payload, is completely separated from the electronics bay. It don't have any cables that go anywhere near the electronics bay. It's I don't. Do you know how what's on the inside? Oh, do I need to explain what the payload does? Or?
How about briefly, because that's really not the subject of this. It's safety.
So we can
but I am curious about it. What are you doing with your payload?
So we are analyzing carbon fibers, carbon nanotubes, and how they agglomerate during high G accelerations. Those carbon nanotubes will be inside 3 different solutions, being alcohol, epoxy resin, and water. And after the flight, we will analyze them and see how they agglomerate within clusters. I think that's it.
Well, sounds like you're on the way to making us a space elevator. I look forward to that. Cool. Now the payload stays attached to the rocket, right? It does not deploy independently, correct?
No, it's not. It goes just inside the rocket. It's not a deployable payload.
Okay, good. No additional safety hazard then. Okay. Can all your electronics be powered up at the pad?
Yes.
Yes, okay. That's not necessarily as relevant to the payload, but all your recovery electronics, anything attached to an energetic needs to be powered down before it goes to the pad. So I'm glad you can do that. When you what is your rail exit? I'm sorry. I don't mean to talk over anybody.
36 metros por segundo.
Okay.
Em pés da conta.
Okay, well, I'll continue. What is your rail exit velocity?
It's 121 feet per second, or 36 feet. 121 feet per second and 36 meters per second.
Okay, that's pretty good. Now, is that calculated with the full 17-foot rail length?
Yes, exactly. The
Okay.
ESRA
There,
provided one.
yes. Now the chains of the way those are calculated, you'll still be okay. But they're now using what is called an effective rail length, which means the length of the rail from usually from the very front rail button, the foremost rail
Okay.
button. So you'll have one at the aft and then another one somewhere up on the airframe, and you have to subtract that distance from the rail length. So do you know the distance? I'm sorry.
So can you repeat the information about what's the effective rail length? It's the top of the rail. Is the length from the top of the rail to the first, the second, or the third? Como que é o nome? Rail guide.
See my finger?
Okay.
Imagine this is
Yes, very good.
This is 17-foot rail, okay?
Okay.
Your rocket is attached to the rail like this. Okay, the effective rail length is from the top of the rail down to your first rail button. That's the rail length, not 17 feet all the way down to the bottom.
So I don't have this data right now. I can provide you with in a 2 minutes. Okay.
No rush on my part, just especially since your length velocity now is 121 feet per second. You'll certainly be within the requirements. But still, that's the way they're recommending that they are requiring that you estimate the rail exit velocity now. So might as well go ahead and have that number for when you do the final review.
Aerodynamics manager is doing the calculations right now. We will give you the numbers in a few seconds.
Excellent. Well, so let me add something to it because you said your first, second, or third rail button. Do you have more than two?
Yes, we have.
Do you have three rail buttons?
We will be using 3 rail buttons. Yes.
Okay, that changes things a little.
Okay.
That changes things a little bit because the way the rule is written, and I'm trying to look. I wrote down the rule number. I'll find it for you. It's your exit from the rail is a point where the rocket becomes free to move in any dimension, except forward and backward. And that's when not necessarily the very top rail button, if you have another one in the middle. And that's actually a good thing because it gives you a little more distance on the rail before the rocket is free to move in other dimensions.
Makes sense.
Yeah. They're going to rewrite that one next year to make it more clear. It was not clear at all in this year's DTAG.
Usually people aren't using 3 buttons, but that's okay.
Yeah. Yep.
So
sometimes more is merrier.
That would be.
I love that.
Top rail button, middle rail button, bottom rail button. Okay. So it's going to be from the top of the rail to your middle button. That's going to be the effective.
We are working on it.
Great use of a finger, Rick. I'm going to start doing that.
And then actually, they're going to have to measure from the bottom to the middle. And then whatever this length is, subtract that from 17.
Yeah.
Because that might be harder from the top of the rail to where there is, because they're not going to know that, but they will know the bottom to the middle. And then subtract that length minus the 17.
Yeah.
So you don't give people the finger, Jimmy?
Not in that context. But I will. Thank you for the model.
I do all kinds of things to convey things to my students.
Oh, yeah. Excellent. Oh, I had this is just a question. You said that you're purifying your potassium nitrate.
Yes.
How do you do that?
So we obtain the nitrate from Sobre a parte de purificação, como é o processo de forma geral.
So our purification method,
Mhm.
we do a recrystallization. I don't know if that's the right
Mhm.
term in English, but where
Yes.
we dissolve the fertilizer that's already 98% potassium nitrate, and within the
Mhm.
recrystallization, we can remove the 2% that is not potassium nitrate and
Mhm.
that are other
Mhm.
adducted and other components to the fertilizer. I think
Yes.
that's the overview of the purification process.
Yes. Well, that's a time-tested method. It's been used for
Yes.
centuries. So
Yes, about for the last 10 years. It was.
I have a cold. Have to take a coffee break every now and then.
Okay. No problem.
Okay, let's see. Let me look back at the sheet. I made a few marks here. Directive Railway, just talked about that. Thin attachment.
So
That.
while we're on the potassium nitrate, where are you going to source your potassium nitrate from?
So on the United States,
Yes.
so you gave us a link a couple months ago that we are just going to buy it online and send to our location.
Okay. And your sorbitol,
And sorbitol, the same.
same way?
I think
Okay.
I think sorbitol is widely available in the US. Or
Pretty much.
is it?
Yeah. I don't know about widely available. Online it is.
Oh, yes, online.
Yeah. Because in past years, teams, when they flew into Los Angeles, they would pick up the stuff from me. And one time I brought it to New Mexico with me, but because they moved up the competition to when I do my competition at FAR, I won't be at in Texas until Wednesday. And you're going to have to start preparing way before then, I
Yes.
think.
Mhm.
So we will buy it online. That's no big deal for us.
Well, something just appeared in HeroX today, and that's a mailing address for the competition that things can be sent to and held. So if you don't
So
have an address to send it to already, then that might be worth of a look.
We already have an address to send it.
Do you?
we
Okay,
already.
good.
Yes. Thank you.
Well, I'm trying to think of anything else to ask you. You've answered all my questions very well. Oh, one thing about the Radax joints. There's a rule in the DTAG about the length of joints where separation occurs. And okay, you got a model there. Yay. Your parachute separation, your deployment separation is going to happen where?
So the parachute separations happens between the main fuselage and the nose cone. So the
Okay.
and the radix joint is just a definitive joint during flight. It doesn't
Okay.
separate. So it's a very,
Okay.
very sturdy joint.
Yes. Yes. I like it. It's just a novel thing. We've not seen those at this competition yet. So you might be prepared to explain that to the reviewer and demonstrate how stiff it is.
Yes.
Yeah.
So
Okay.
do
But
you? No, you
yeah,
can go
I'm
on.
satisfied. How about the nose cone? Does it pop off easily? Is it held in with shear pins in flight? How are you
So
going to
it's
secure
held
that?
in. So during flight, there will be 4 sharp pins that will attach the nose cone to the main fuselage, but the connection to
Okay.
there is enough friction between them that's kind of hard to pull them. But
Okay.
during our ejection test, there was no problem. Segura tudo mais aqui.
Oh, a nice long shoulder. I like that.
Yes, I think it's 1.5 calibers.
Yes, that's plenty. Now, are you using shear pins in addition to friction?
Yes. Though
Okay,
we will
good.
be using
Yep,
3D
it's a shear
printed
pin, all
resin.
right. So you print those?
Yes, we did.
Okay, good. Okay. Oh, and I love seeing the videos of you testing the reefing release for the parachute. That looked like fun.
You saw them.
Oh yeah, I watch every video. I love a good film. Oh, is there a video of your recent static test available?
Yes, we do. We will show you right now.
Oh, okay.
We will try to share our computer screen right now so you can see it better.
Okay. Well, if it works, but if you want, just put it out there and tell me where it is. I'd be happy to watch it. But yeah, pull it up if you can.
We will try to pull up right now. We haven't uploaded the video anywhere yet.
Okay. Oh, whoa. Looks like we're there.
Can you see the screen?
Okay. Oh, yeah. Nice film noir.
So on the left side, you can see a bunch of sandbags covering the motor because we were a little scared from what happened on the past test. And we will unpause the video right now.
Okay.
Can you hear any sound from the video?
I don't.
No, but I don't need to.
No. So as you can see from the video, it was a very stable combustion. The pressure from the angle of the flames was very steady. It didn't change throughout the fire, and that's a good indication of the comportamento. That's a good indicator of the behavior of the insides.
Yes. Didn't see a lot of fishtailing. It's very good. It looked like it started a bit slow. That it was a progressive burn.
So from our parameters, we would say that the thrust went up very quickly. The initial flame was from the igniter, not from the grains itself.
Okay. Well, I just see the flame getting bigger and bigger as the motor burns. And I wonder if that translates into thrust or pressure. What did your pressure curve look like?
I didn't had enough time to evaluate the pressure curve from yesterday, so I can't answer you with a definitive answer.
Okay,
you
well,
play?
send it to me when you can. I'm sorry.
Yes. As
Can
soon
you
as I
play it
can.
again?
Pode tocar de novo o vídeo. Ok. Tenta ver se tem transmissão de áudio. Sim. Tem que transmitir janela, não?
Não, já tem só.
Ok. So,
Oh, sound.
Oh, your time disappeared when the motor started firing. I was going to see at how many seconds before it looked like you had usable thrust.
Não, eu fiz comentário apenas.
Did you
If
want
you
to play
do,
it again, Rick?
yeah, if you do it again and kind of move your finger on the screen so that it retains the second count timer under. Okay, that looked better that time, but the numbers are so tiny, it's hard for me to see. Let's see if I got the glasses here.
As soon as we have the exact seconds between from the actual start from
Okay,
up to the usable thrust, we will send you
okay.
if that's fine.
Excellent. Yes.
Okay, yesterday at FAR, we fired a sugar motor, and it was 13 seconds before it came up to full pressure.
So,
Oh my goodness.
And that was only because the grains were left out in the rain, and it took a while to burn off all the outside fluff.
My goodness. Was there anything else you would like me to know or say, or questions,
Alguma coisa
comments?
extra, galera? Pra comentar?
Well, thank you for asking that question. I was glad to have a good answer for you.
so there was a question about the rail exit velocity and using
Oh, yes.
So we will be having a 101 feet per second rail exit velocity using the effective rail length. That's just
Excellent.
about what's permitted allowed on the
Yes.
competition.
That's good. And you're going to be one of the few teams that is actually meeting the original IREC requirement of at least 100 feet per second.
Oh, really?
Because you
The
can
other-
go lower as long as you do a thorough stability analysis, and everybody's doing that anyway.
Yeah.
But you'll be in the top tier.
So most of the teams are going below that 100 feet per second velocity?
Everyone that I'm working with, except for you, are below that velocity. And it's not really a problem as long as they don't go in the vicinity of 50 feet per second, because then they're not allowed to fly at all. And I've had some that were in that vicinity. But so far, everybody's been able to fix things. So I think everybody will have a flyable rocket, at least all the teams I'm working with.
I don't
Which
have
mean-
any more questions about the.
Well, if you come up with some, send me a note. I'd love to talk
Okay.
and continue our conversation. I love working with you folks. You're a great team, very smart, very pleasant, and you like rockets, and you're making a big sugar motor. I really like that.
I think
I have a
Rick
quick
also
question.
does love
I have a
that.
quick question for you guys. Are you able to fly a motor of that size in the last competition?
The last competition have actually three categories of apogee and three tiers. And there is 500 meters, 1 kilometer, and 3 kilometers. And the competition doesn't allow this rocket size, this rocket apogee of the competition.
Okay.
And unfortunately.
Oh, okay.
Is that
What is
something set in stone, or is there like a future time when they could allow a higher apogee?
So the main competition that happens in Brazil is the
LASK.
LASK, Latin America Space Challenge, and I don't know if they have any future plans to get higher and higher apogees. The top ceiling right now is 10,000 feet. That's about 3 kilometers.
So you have to add a lot heavier payload to the rocket.
And actually, on ESRA, they allow a lighter payload than on the Latin America Space Challenge that we compete on Brazil. So that's a good point for us to get a.
Yeah.
It's not, it's
Okay.
absolutely good.
Yeah. Just waiting to see if I have any further questions come up, because sometimes they pop in.
Let me
And while
think
you're
first.
thinking, turn the camera around. Let me say hi to everybody else in the room. Hello, everybody. Congratulations.
Thank you very much.
Okay. I'll submit my report sometime real soon, and it will be favorable.
Okay.
Any more from Rick? Further questions, comments?
No, I have complete confidence in them from the previous times that I've seen them come to the competition, and I know they'll do a great job.
I believe so too. Oh, and I liked your LoRa test video, the long range radio. And I think it's just so nice of Brazil to provide you a nice seacoast to do it at. Yes.
Yeah, it's very near from here. That was actually the easiest of the places to have such a clean long range testing site.
Well, I might adopt that idea too, because we've got some nice long beaches here too. Yeah.
Just a comment, but for Brazil, it's a very, very big project. Our team is the only one team in Brazil that actually have did a rocket of the size before, and
Yes.
we are going to represent this country on this competition. So we are very,
Yes.
very proudly of this work. This is amazing for us, and
Yes.
yes, this is very, very fun.
Well, I'm very proud of you. You're doing great work, and for a good cause. Okay, are we ready for bye-bye yet?
Yes, we are. Good.
All right. Anyone else before we close out? Well, thank you for a lovely time. I've enjoyed this.
Thank you.
We'll see you in New Mexico, if not sooner.
Thank you, Jimmy.
New
I'm sorry, in
Mexico.
Texas. We'll see you in Texas. Then we'll go to New Mexico.
Yeah. See you.
See you. Bye.
All right, here we go.
Bye,
Bye-bye.
Bye.
Take care.
Bye, Rick.